In the vast darkness of our solar system, Saturn's moons often go unnoticed beside their giant host. Yet some of these moons hold secrets that challenge our understanding of planetary formation. Tethys, a small, icy moon of Saturn, is one such enigma. At just over 1,000 kilometers wide, Tethys orbits Saturn closer than our own moon orbits Earth. Its surface is dazzlingly bright, made almost entirely of water ice, a cosmic snowball. For centuries, Tethys was just a point of light, its mysteries hidden. But when robotic explorers arrived, they found features that defied expectations. Vast canyons and giant craters scar its surface, out of scale for such a tiny world. These discoveries forced scientists to question how a moon like Tethys could even exist. Its features seem to break the rules of moon formation. Tethys is more than a frozen ball of ice. It's a cosmic crime scene, holding clues to a violent past. By studying Tethys, we piece together the story of Saturn's system and our own place in the cosmos. The universe is full of wonders, and Tethys is one of its most intriguing. Let's journey to this distant, impossible moon. We'll explore its vast canyons, giant craters, and the scientific debates about its origins. Tethys isn't just a moon, it's a key to understanding planetary evolution. Its very existence challenges what we thought we knew. The story of Tethys is a story of surprise and discovery. It's a reminder that even the smallest worlds can hold the biggest mysteries. In the end, Tethys invites us to rethink the rules of the solar system, and that's what makes it truly extraordinary. For centuries, Tethys was a distant mystery, until the Cassini-Huygens mission arrived at Saturn in 2004. Cassini's powerful instruments brought Tethys into sharp focus for the first time. High-resolution cameras revealed a world marked by scars and craters, not the quiet, frozen surface scientists expected. Cassini's flybys mapped vast canyons and measured the depths of giant craters. Spectrometers and radar uncovered subtle variations in the ice, hinting at a complex chemical story. The images were shocking, features so enormous they seemed impossible for such a small moon. Tethys, thought to be geologically dead, showed evidence of immense trauma. The data forced scientists to rethink everything they knew about small, icy moons. Instead of answers, Cassini delivered new mysteries. Why is Tethys so heavily scarred? What forces shaped it? The mission transformed Tethys from a point of light into a world with a dramatic story. Every new detail raised more questions about its origins and evolution. Cassini's legacy is a foundation for ongoing debates about Tethys. The moon's surface became a map of ancient violence and cosmic change. Tethys emerged as a place, not just a name, a world with secrets still waiting to be uncovered, and the search for answers had only just begun. Among Tethys's features, one stands out: Ithaca Chasma, a colossal canyon system. Stretching over 2,000 kilometers, 3/4 of the moon's circumference, it's up to 100 kilometers wide and 5 kilometers deep. On Earth, a canyon of this scale would span continents. But Tethys is a frozen, airless world. No rivers, no wind, no rain. So how did such a canyon form? The leading theory: Tethys once had a subsurface ocean. As the moon cooled, the ocean froze, expanding and cracking the icy crust. The result: Ithaca Chasma, a scar from immense internal stress. But some models suggest this process alone can't explain the canyon's size. Another idea links Ithaca Chasma to a massive impact on the opposite side of the moon. Could a shock wave from a colossal collision have fractured the crust? Whatever its origin, Ithaca Chasma reveals a violent, dynamic past. It's a wound that tells a story of planetary upheaval. Tethys's surface is a record of forces far greater than its size suggests, and Ithaca Chasma is the moon's most dramatic chapter. On the opposite side of Tethys, from Ithaca Chasma, lies Odysseus Crater, one of the largest impact craters relative to its host in the solar system. At 450 kilometers across, it spans nearly half the moon's diameter. The impact that created Odysseus was cataclysmic, yet Tethys survived. Strangely, the crater is flat, not deep and bowl-shaped. This suggests Tethys's crust was warm and soft at the time, almost slushy. Over time, the crater relaxed, its features smoothed by the pliable ice. This fits with the idea of a once thin, warm crust, possibly above a subsurface ocean. Some scientists propose a direct link. The Odysseus impact may have sent shockwaves through Tethys, helping to create Ithaca Chasma on the opposite side. The fact that Tethys wasn't shattered by the impact is remarkable. Odysseus crater is more than a scar. It's evidence of survival against cosmic odds. It shows that the early solar system was a violent place, and Tethys was right in the firing line. The crater's shape and size are clues to the moon's internal history. Tethys's resilience is as mysterious as its scars, and Odysseus remains a testament to the chaos of planetary evolution. Cassini revealed another puzzle: faint reddish arcs on Tethys's leading hemisphere. These wispy lines stretch for hundreds of kilometers, yet are only a few kilometers wide. They're not linked to craters or canyons, and their origin is a mystery. The red material is chemically distinct from the surrounding ice, possibly organic compounds or dust from elsewhere. Some theories suggest outgassing from fractures, while others propose the arcs are debris swept up from Saturn's outer moons. The arcs are only visible in special lighting and through color filters, making them easy to miss. Their discovery highlights how much we still don't know about Tethys. Each new observation leads to more questions. The red arcs are a tantalizing clue to hidden processes at work. They remind us that even the simplest-looking worlds can surprise us. Tethys's surface holds secrets waiting for future missions to solve. The greatest mystery about Tethys may be its very existence. Tethys is almost pure water ice with little rock, yet it orbits close to Saturn, where it should have formed as a rocky moon. Standard models say the inner Saturnian system was too hot for ice to survive. So, how did Tethys form here? The contradiction challenges our understanding of moon formation. Some suggest Saturn's accretion disk was colder than we think. Others propose Tethys formed farther out, then migrated inward. This idea of planetary migration is now central to modern astronomy. Tethys's composition and location force us to rethink the rules. Its presence is a puzzle that standard theories can't solve. The moon's icy nature in a forbidden zone is a major clue. Tethys may be evidence of a much more dynamic early solar system. If slow accretion can't explain Tethys, what can? Some scientists propose a catastrophic origin, a collision between larger moons. This impact would have created a cloud of debris, rocky material lost, icy fragments remaining. Over time, the ice reformed into new moons, including Tethys. This explains its pure ice composition, and may even account for Saturn's rings. Tethys could be a second-generation moon, built from recycled fragments. The theory paints Saturn's system as a place of destruction and rebirth. Proving it is difficult, but Tethys's scars and composition support the idea. The moon's history is one of chaos, not quiet formation. Tethys is a survivor of cosmic violence, a product of catastrophe. Tethys doesn't orbit Saturn alone. Two tiny moons, Telesto and Calypso, share its path, locked in stable positions called Lagrangian points. These Trojan moons orbit 60 degrees ahead and behind Tethys. They're small, icy, and irregularly shaped, cosmic potatoes in a gravitational dance. Their origins are uncertain. Did they form with Tethys, or are they debris from a past collision? Their smooth surfaces suggest a coating of fine ice dust, possibly from Saturn's E-ring or impacts. Studying these moons reveals how material moves between Saturn's satellites. The arrangement is a beautiful example of orbital mechanics at work. The Tethys Trojan system has survived billions of years of chaos. These companions are part of Tethys's story, a family bound by gravity. Even in space, no world is truly alone. The Trojan moons add another layer to the enigma of Tethys. Cassini transformed our view of Tethys, but left us with more questions than answers. The next step is a dedicated mission, an orbiter to map the surface in detail, or even a lander to sample the ice. High-resolution cameras could reveal the red arcs up close. Ground-penetrating radar might find evidence of a frozen subsurface ocean. Advanced spectrometers could finally identify the mysterious red material. A lander could drill into the ice, uncovering secrets from billions of years ago. Tethys is a cosmic anomaly, a world that breaks the rules. Studying it could force us to rewrite our theories of moon and planet formation. The exceptions often lead to the biggest breakthroughs. Tethys challenges our assumptions and pushes the boundaries of knowledge. Its surface holds clues to the violent, beautiful history of our solar system. The story of Tethys is far from finished. Each new discovery brings us closer to understanding our origins. Tethys's mysteries are an invitation to explore further. The next chapter in its story is waiting to be written.